Welcome to the island of science. I hope you are enjoying fun do science. Length, as we were discussing, it is a distance between 2 points. Today we will take length as a fundamental quantity and how we derive quantities from this fundamental quantity. That concept we are going to discuss. Length is distance between 2 points. This distance can be smaller one or it can be larger one. Before going for measuring the distance or length, let us see how this length is defined. As discussed, in MKS unit, meter is defined as a standard unit of measurement for length. Now, how much should be a meter? How to define that? So, SI system, which is governing all this system of measurement and defining it for whole world, that SI system has devised a rod and marked a standard length for 1 meter. It has taken 90% platinum and 10% iridium alloy, devised a rod and marked 1 meter length on that rod at 0 degree centigrade. This 1 meter defined length is preserved in the International Bureau of Weight and Measures in Paris. Now this length of 1 meter is accepted universally as a 1 meter. When we divide this 1 meter into 100 equal parts, then each part is defined as centimeter. Similarly, when we divide this rod into 1000 equal parts, this length into 1000 equal part, each length is considered as 1 millimeter. Now, if you want to see the millimeter and centimeter, you can open your compass box. You have a ruler, which is a standard device to measure length as a sub-unit, sub-multiple unit. So you can see millimeter, what is the length of a millimeter and what is the length of a centimeter. This length, as I told you, is having a standard device as a ruler. Now, there is one important terminology that is called as least count. Now, what is this least count? Any instrument which is used to measure any quantity, the minimum quantity that it can measure is called as least count of that instrument. That means if I have taken a ruler, you have to see which is the minimum length that ruler can measure. Suppose in your compass box you take out your ruler, you will see that ruler can measure minimum 1 millimeter length. So least count of ruler is 1 millimeter. Now with that ruler, we are going to perform certain activities and we are going to see how this length can be used to devise various derived quantities. For example, if I want to find out the area of certain field, I have to measure length and breadth of that field, multiply length and breadth, and we will get area. So area is derived quantity. Now you know the unit of length is meter, the unit of breadth is also meter, and if I multiply both these units, we will get meter square. That means the area, the unit of the area which is derived quantity is meter square. So many more such activities we are going to perform. So let us go to our work table and perform certain activities. This is a scale. Okay, we call it scale in our layman's language, but this is a ruler. I show you, it starts from 0 and the minimum length it can measure is 1 mm. So least count of this scale is 1 millimeter. Now it is divided into centimeters and this side into inches. We are going to deal with centimeters only because it is MKS unit. Now I told you the application of this. Now suppose I have this very known Rubik's cube to you and I want to find out the area of this Rubik's cube in 2D form. So first thing, I would like to measure the length and breadth of this cube. I have drawn the outline. Now if I measure it, it is approximately 5 centimeter length and 5 centimeter breadth. So if I find out the area, I have a formula, length into breadth, which is 5 into 5, and it is 25 centimeters square, because I am multiplying units also. Here centimeter I multiplied, so I have a unit for area as centimeter square. If it is a field, it is meter square, because it goes to the larger thing. This is about regular solids. Okay, when we have regular shaped solid like this, it is regular shaped, well defined boundaries, so I can use this. But suppose to be, if I have irregular boundaries, that means a stone or something which do not have a defined boundaries, in that case I use this graph paper. Suppose to be, I have some stone like this. It is not a defined shape. I cannot say it is a circle. So what will I do? I place my object on the graph paper and its irregular boundary I trace. Next, what I have to do is count the number of squares which is present in this graph, and inside this circle or this shape, inside this irregular shape, the number of these squares will indicate the area. Now I will count the squares which are complete, which are not cut from any side. So those squares I am going to count. So I have made the dots here. As you can see, I have 15 such squares which are complete. Now I am going to see the squares which are just cut and not half cut. They are 2 in shape, which I can consider 3/4. Now I have to count the squares which are half cut, which is 3 in number. Count the square which are just partially cut. So if I add this up, I have 19.5 centimeter square as the area of that irregular object. This is just a method which you follow to calculate the area of irregular objects. Let us consider one more unit, one more derived quantity which is devised from length. We have considered area here. Now if this cube is given and volume is asked, then do you know what is volume? Volume is how much space it occupies or how much quantity of the substance it contains. So that is volume. So here to calculate volume, we have to calculate length, we have to calculate breadth, and along with length and breadth we have to calculate height also. We know the length of this cube is 5. We have measured the breadth of this cube. Now we have to calculate the height of this cube. So we are going to calculate the height of this cube, which is again 5 centimeter, and the volume of this cube is coming as 125 centimeter, and again because I am adding one more centimeter, it will become cube. So the measurement unit for volume becomes centimeter cube. This is how we are going to measure the quantity or volume in terms of units. It is regular shape, so it is easy to calculate. Now suppose if I will give you certain object like this, what will you do? It is difficult. you have just one ruler, okay, and with the help of this ruler you have to measure. So I have an idea. I will keep one sharp edged object at 0 here like this. Then I will place my object which I have to measure, which is round in shape or sphere. Then I will take one more box like this, and holding the scale I will push so that both the edges are touching each with the boxes. Okay. Now I have to take the reading. It is 3 centimeter. So I got 3 centimeter reading. What is this 3 centimeter? It is nothing but diameter of that sphere. Okay. That means suppose this is a sphere, then this length, diameter, the biggest chord, that is 3 centimeter. Now if I have to find out the volume or area or circumference, I can use this 3 centimeter, putting it in different kind of formula, and find out the volume as well as circumference, radius, anything from this measurement. Now this is your homework. You can do it at your home. You know the formula, and anyhow I am going to put this formula for you in this slide also, in this video also. Suppose this object is given to you and thickness is asked. Then what will you do? I have this divider in instrument, and it is similar to calipers. Okay, caliper is an instrument which is used to divide, to measure the thickness. Now what will I do? First thing, I will measure the internal length of this by touching. Here you can see, by touching just the point to the wall, touching the point to the wall, I will measure it. It is coming as 7.5. I will note it down. Internal diameter is 7.5 centimeters. Now next what will I do? I will draw an outline of the sphere. It is easier to do, so I am doing. You can directly also do that, and measure the diameter using this caliper, or you can say divider. I will measure it using my scale. It is 9.5. External diameter is 9.5 centimeter. So if I subtract external diameter with internal diameter, I will get the thickness of this substance or this object. Suppose this thin object is given to you and its external thickness, the thickness of this object is asked. So scale you cannot bend, calipers बहुत ज़्यादा thick, it is very small, so very difficult to measure. So what will you do? You have marker pen. I am going to mark this thin object as 0. I have marked this thin object as 0. Now what will I do? I will take a thread. I will keep this thread on this mark and just on this mark and wind it tightly. 2 winds, 3 winds, 4 winds, and I will end it just at this mark from opposite side. Now I have wound this wire 5 times. Now I will release it. Measure the length of this thread. It is coming as 7.5 centimeter. The length of 5 winding is 7.5 centimeter. So length of one winding would be 1.5 centimeter after calculation. So I can say the circumference of this thin object is 1.5 centimeter. So circumference is nothing but 2 pi r, which is 1.5 centimeter, and from this I can easily find out radius of this thin object, and I can use this data for finding out various other calculations. Now here I will suggest you one precaution while measuring all this. You have this scale or a ruler. Now you have to, while measuring, you have to see the object, the reading of this ruler right from upward direction. That means just from upward direction, just keeping your eye. This is supposed to be your eye, and it should be just above the reading. If you will watch from this angle or from this angle, you are tend to make mistake. Okay, and you will end up getting wrong reading. This error is called as parallax error. Okay, so while taking reading, you have to take precaution that you are taking reading just perpendicular to the object, so that you will not end up doing parallax error. Here, this I have made a flexi scale. It can bend, and you can use this flexi scale to measure various things. And as you can see, I have made this using graph paper. Suppose this object I have to measure, I can use this flexi scale very easily to find out the measurement. You can also make this at home. I hope you enjoyed the session. Doing various activity. I hope you would have also replicated this activity along with me. I have one activity for you also. You have to take a stack of coin, count the number of coin, measure the length of the stack of coin. Whatever length you get, you are going to divide that length with the number of coins. You will get the thickness of each coin in that stack. The precaution you have to take, that coin should be of same type. If you are taking 10 rupee coin, all coins should be 10 rupee. If you are taking 2 rupee coin, all coins should be of 2 rupee. Try to take at least 10 coins. It will help you in calculations and measurement. One more thing, one question I left is that what about irregular solids? If solid is irregular, how would you measure the volume of that solid? So what you have to do, you can take one measuring cylinder, as you can see in this picture. Tie your irregular solid with that thread. Note down the reading of meniscus of the liquid or water inside the measuring cylinder. That reading will be your A1 reading. Now dip the irregular solid with the help of thread inside the liquid. You will see there is a raise in water level. Now again note down the reading. That will be your A2 reading. If you will subtract this A2 from A1, you will find the difference between the two levels of meniscus. That difference is the volume of irregular solid that you have taken. So today we learned how to find out area of regular object, irregular object by using length. Similarly, by using length, how to find out the volume of regular solids and irregular solids. So I have also given you one homework. You have to find out and comment in my comment box. So see you in next video. Till then, bye bye.